This is my Arduino project for term 3. My project is using the Arduino 101 board, several tutorials and code compilations to create a Ram Bolt security door lock. A Ram Bolt security door lock works as though it's an iron stud like this. When the solenoid activates, it either pulls it back or fires it back in to create an emergency lock that will not open no matter how much you try to move the door. I've currently nicked this up so you can see when the actual thing moves. When I trip the temperature sensor over here, like say remove the temperature sensor out of the condition to create the circuit to work, you can see it fires back. Whenever I say turn off the circuit, the pin will fire back out and go back to locking the door. When you trip it again, it will shoot back in, and that's the point of all these tick marks over here, and I can't really remove the pin because the magnetic field on it is so strong. It can go back a little bit deeper like that, but that's just because I have a large iron spring in there instead of a large, say, steel spring that's not as magnetic. When you release it, on full pass, when it's all the way back and the spring's fully cocked, it will shoot all the way back out. When it's in a door frame, it will actually lock into that position on the other side of the door, and you can't move the door as much as you try. When we come back over to here, you can see that the temperature sensor is reading thermal yes because, as I said earlier, the temperature sensor was temporarily removed to give a clear illustration of what happens when the temperature sensor is tripped without me having to reliably activate it. When you put this back in until the temperature sensor, the code realizes that the temperature sensor is back where it belongs, the temperature sensor will still run like this, like it normally should. Over here, we also have the addition of when the degrees are over too high, right now currently it's 100 degrees. When it's too high or above average body temperature, the thermal indicator will not register a body temp. Either when it's below 65 degrees or above 100, the only way to open it will be using this button right here. You'll be able to press it, indicating to the system that something's not right or something is currently locked. Over here, under the degrees, F equals 78 degrees is the average temp of your fingers. So that's what you're going to use to trip the temperature sensor into firing the solenoid over here, which, as I said again, is currently using a magnetic pulse to pull the pin from out here, which is locking the door, into the solenoid, and you can open the door. That's pretty much how my program works. This is my Arduino One project. My project is the encompassment of 4 separate tutorials. These tutorials include the LCD display, which is listed over here on both the schematic and the breadboard. Then it is also using the temperature sensor, the blinky LED, and controlling a PWM based device. My actual circuit uses a servo, a solenoid in place, and the servo is currently holding the place of that because there is no part on fritzing. These things are pretty simple to understand. They just easily display the Arduino setup, each individual ports. These ports over here are mainly for the LCD display. Port number 9 is actually controlling the PWM on the servo. In my case of when I use the solenoid, it is controlling the white line, which is the solenoid's PWM, which is telling it when to turn on and off. Over here, the schematic is just a separate type of representation of that very same thing. Over here, we have the temperature sensor, the potentiometer to control the brightness on the LCD. And that's pretty much how these two work. You come back over here and we have the Arduino actual code. The program is designed to work as a door lock. The door lock works as in whenever a certain degree is met, such as the temperature sensor reaches its degrees required, it will unlock. And when the degrees are in a set where it's over 100 degrees or when it's more than an average body temperature, the thermal register will not work. You have to use the emergency button to either lock it or open the system. The schematic is also simple as well. The schematic uses the potentiometer to control its brightness, and then it will also display the LCD notifications, which are when thermal indication is reached and when the door will open and the required degrees met. If 10 degrees higher, it will not register and will shut down and seal the door with a steel rod. The code is pretty simple. I'm using several things: the button, the temp pin, the LEDs. I'm using several floats for thermal and the temperature degrees. Down below we have the LCD set up, the clear, begin, and the print for the system on, which is only displayed for about 4 seconds before the system registers. Down here we have the display of the degrees required to meet. It's currently 80 degrees Fahrenheit. And as we go down, it's just more the volt system and requirements and the serial active prints. Down here is where we get to the actual loop of control. Thermal print, yes, this loop right here is, in a sense, the loop that runs the whole program. We have the button for the readout. Currently, this version of the code is still in its beta form, so it doesn't have it edited right now because I was having issues with compiling. The LED 1, which turns it to high to tell the LED on. Set the cursor to 0, 1 to print on the top line. And then to print thermal yes, which is thermal recognition. And then it will analog write pin number 9, which is to the solenoid, and we'll tell it 0, which turns it on. And we'll tell the solenoid to pull the pin back and continue on. Anything else, it will clear the LCD, write 255, which is off, set it to the top, to the bottom bar, and we'll print thermal no register. Coming back over here, we also have the active serial monitor, which when I place my finger onto the thermal sensor, as you can see down here, the temperature rises, and when it reaches 80 degrees, the LED will trip and the system will turn on. When the system turns on, the solenoid will turn on, pulling the pin away from the door, and will allow you to open the door for as long as either the temperature is met or until the button has changed its value. That is pretty much how my program works. Thank you,